Welcome. This is part 3 of our detailed look at our Smart Servo robot arm. We went through this code last time in some detail. We talked about how this node responds to the servo topic, and based on whether we get a home or a reach or a wave or a position statement, it's going to do a certain set of things. Let's go now into some more detail on how we came up with the angle home and the angle reach part of this code. So let's look at our arm. Go over here and look at our arm and look at some things. So here's our arm. We're looking down at the top of it. And what we have to do for each of our servos is we have to look at our servo and discover, well, what's the 0 location, what's the minus 90 location, what's the plus 90 location. I think if I had been more careful, these would be defined the same, but I wasn't. I constructed the arm and then I went back and looked at each of the servos, and I used the Dynamixel wizard to understand where the 90 and the minus 90 and the plus 90 location was. So for example, we can look at, this is our Dynamixel. If I select one of these servos, I can go over here and I can ask it to go to 0 or minus 90 or plus 90, and it will go to that location. Then I can move it to minus 90 and plus 90. And then I captured that information on these slides. So for the base, this is minus 90, we'll put it over here, plus 90, we'll put it over here, 0 puts it going straight forward. For the second servo, for this first bend servo, which by the way, I used the AX18 for, it's got a little bit more torque because it's got to handle the weight of the arm. I configured that so that the 0 location is straight up, minus 90 is this way, plus 90 is this way. On the next one, I did a little bit different because I wanted 0 to be this way because I might want to take it further than just straight out. This particular arm, I'm not going to ever want it to bend backwards, but I might want it to bend a little further forwards. So I actually constructed it to be 0 and minus 90 and plus 90. And then the final step, of course, was to come up with what does open and what does closed look like. So that gives me all of my different locations. Then I use the Dynamixel wizard on the laptop to look at all this information. And then I went back to the actual program. So this is the program, and I was able to determine, well, what is the fundamental location for each of these things. So where is 0 and where is 90 and that kind of thing. So this allowed me then to come up with what these values should be. And so now I've got everything set up. So if I were to go ahead and say go home, it should go straight up. Let's see if I've got a picture of that. It should look something like this. So if I go home, if I give it a home command, it will go up and look something like this. If I, however, give it a reach command, it's going to go something like this. And again, I just checked the angles, made sure everything worked such that it was correctly controlling the robot arm. Now, in the next video, we're going to go a little bit further. We're going to go ahead then and start figuring out how do we calculate something that isn't just a home location or a reach location, something that's fixed, but rather what do we do if we want to look at something that is a different location?